Hello students, welcome to chemistry online classes. We are now in lecture 10. In last class we started learning about ionic equilibrium. We have classified substances into electrolyte, non-electrolyte, again classified electrolyte into strong electrolyte, weak electrolyte. We have seen various examples, and also we have completed various concepts of acids and bases. Arrhenius concept, Bronsted-Lowry concept, as well as Lewis concept. And most important thing is, if example is before us, we should be able to distinguish which type of acid we are talking about. Now today we will go ahead and we will learn about the dissociation of water. Dissociation of water. In fact, we are learning one important concept here called as ionic product of water. Now we will take H2O in liquid state. It combines with another H2O molecule in the liquid state, and it forms hydronium ion in aqueous state. OH negative ion in aqueous state. Now if we look at these two molecules, this H2O gets converted to hydronium ion and this H2O gets converted to the OH negative ion. Now how H2O gets converted to H3O plus? Of course by accepting proton, because there are two hydrogens here. Here are three hydrogens. So one H plus has to be added. So H2O becomes H3O plus. So we can say that this is by accepts proton, and that substance which donates proton is called as acid, and that which accepts proton is called as base. Look at another H2O molecule which has been converted into OH negative. How H2O gets converted to OH negative? It donates proton, and that's why it gets converted into the what we call it as an acid, because H2O is giving proton and becomes in the OH negative. So this example we call this as autoprotolysis. Autoprotolysis, because same substance. Auto means self. Proto means proton, lysis means breaking. Same substance is giving proton and same substance accepting proton. We call it as amphoteric substance also. But this reaction we call it as autoprotolysis. Now we can write the at equilibrium, because this reversible reaction. So equilibrium will definitely a stage which comes into the course of reversible reaction. We write the equation for it. It is the molar concentration of product, which is hydronium ion and OH negative ion, divided by molar concentration of reactant, which is H2O squared. As we are dealing here with water, we can write substitute here W. We call it as KW, which is nothing but equilibrium constant for dissociation of water, also called as ionic product, because this H2O is a pure liquid. That's why its molar concentration is supposed to be unity, 1. That's why we can say this ionic product equals to hydronium ion concentration multiplied by hydroxyl ion concentration. So this is the product of molar concentration of hydronium ion and the hydroxyl ion. That is called as the ionic product. We can replace this H3O plus as by H plus ion, because that's what we always say, that when H2O is dissociated, H plus ion and OH negative ions are formed. So this can be replaced by this. This is also the equation we can use here. Now at 298 Kelvin, which is nothing but 25 degrees Celsius, the value of this ionic product of water is 10 raised to minus 14, which is constant, and the unit is of course mole per liter square. Now, why this 10 raised to minus 14 we can say? We can say Kw is nothing but H plus ion concentration multiplied by OH negative ion concentration. And that's what both concentration equals to 10 raised to minus 14. It is temperature dependent because being equilibrium constant, it is temperature dependent. And as temperature increases, ionic product of water also increases. So we have to remember the definition and the value. The most important thing is we can calculate H plus ion concentration if they give the ionic product of water, which is nothing but ionic product of water divided by hydroxyl ion concentration. Or we can calculate the hydroxyl ion concentration, which is nothing but ionic product of water divided by H plus ion concentration. So all these results, which are in the form of formula, are important for us because we use them at appropriate time in the numerical question. So ionic product of water is nothing but is the product of molar concentration of hydronium ion and hydroxyl ion. At 298 Kelvin, its value is 10 raised to minus 14. It means molar concentration of H plus ion is equal to into molar concentration of hydroxyl ion is equal to 10 raised to minus 14. This value is 10 raised to minus 14. This also 10 raised to minus 14. If temperature is 298, if temperature increases, dissociation is more. Dissociation is more means this H plus ion OH minus ion concentration is more, and its value is also greater. But at 298 Kelvin, the value is 10 raised to minus 14. Now we can use this ionic product of water to classify the solutions into acidic solution, basic solution, neutral solution. See how we are going to do that. If we take the aqueous solution of any electrolyte, aqueous means in water, solution of an electrolyte, and compare their H plus ion concentration and OH minus ion concentration. There are three possibilities. See which possibilities we are talking about. We are comparing the concentration of H plus ion and the OH minus ion. The first possibility is that their concentrations are equal. If it is so, we say that that particular aqueous solution is neutral. If H plus ion concentration is greater than OH negative ion concentration, that particular aqueous solution is acidic. If OH negative ion concentration is greater than H plus ion concentration, that particular solution is basic. So these are the three possibilities. By comparing the hydronium ion concentration or H plus ion concentration with OH negative ion concentration, we can have these three possibilities. If both are equal, it means H plus ion concentration is equal to OH minus ion concentration is equal to 10 raised to minus 7, because H plus ion concentration into OH minus ion concentration is 10 raised to minus 14. So 10 raised to minus 7 multiplied by 10 raised to minus 7 is equal to 10 raised to minus 14. So H plus ion concentration is equal to OH minus ion concentration, and that equals to 10 raised to minus 7 mole per liter. If solution is neutral. If it is greater, acidic. If it is less, it is basic. But the product of H plus ion OH minus ion is always 10 raised to minus 14 if temperature kept constant, because it only depends on temperature. If H plus ion concentration is greater means OH minus ion will be lower, so that the product of H plus ion concentration and OH minus ion concentration is equal to 10 raised to minus 14. That will remain as long as the temperature is 298 Kelvin. So that's how we can identify the aqueous solution, whether it is acidic, basic or neutral. one scientist has made one scale, we call it as pH scale. This is also very important concept in analysis. So many one after another concepts we have to understand here. This concept is called as pH scale. So one scientist, French scientist Sorensen, has done this. What he has done? He has made one scale. The scale is used to compare or to measure. The same is the application, same is the use of scale here. So he used this pH scale on the concept of pH, which is nothing but proteins of H plus ion. What do we mean by proteins? Proteins is potential, which is nothing but activity of H plus ion, which is nothing but, in our textbook we use this activity as similar to the molar concentration of H plus ion. What is the difference? The activity has no unit and molar concentration has unit, molarity. So H plus ion, if you express in molar concentration as unit, mole per liter. Expressing activity, it has no unit, because activity is nothing but concentration divided by standard concentration. Being the ratio of concentration to concentration, it has no unit. But molar concentration, it has unit, mole per liter. So how he made scale? He made scale depending on this formula. pH equals to negative log of H plus ion concentration. Use this formula to calculate this. So there is logarithmic relationship between pH and the H plus ion concentration. We can calculate H plus ion concentration by this formula using this. This will be 10 raised to minus pH. Or we can calculate the H plus ion concentration by formula anti-log of minus pH. In this way, we can use this three formula to calculate the pH or H plus ion concentration. So, what type of scale he made? It is like starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. He said these are nothing but pH of these various solutions. What is the H plus ion concentration here? 10 raised to 0, 10 raised to minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and minus 7 means this point corresponds to neutral pH. This is 10 raised to minus 8. It go on decreasing now. Minus 10, minus 11, minus 12, minus 13, minus 14. These are the H plus ion concentration. What are the OH minus ion concentration then? 10 raised to minus 14, 10 raised to minus 13, so that they becomes equal to 10 raised to minus 14 if you multiply them. This is 10 raised to minus 12, this is 10 raised to minus 11, this is 10 raised to minus 10, this is 10 raised to minus 9, this is 10 raised to minus 8, this is 10 raised to minus 7, so that it becomes neutral. This is 10 raised to minus 6, this is 5, this is 4, this is 3, this is 2, this is 1, this is 2. So he said that if pH is less than 7, it means the H plus ion concentration is greater than OH minus ion concentration, because minus 1 is greater than minus 13. So these solutions are acidic solutions. These solutions are acidic solutions. And if pH is greater than 7, it means OH minus ion concentration is greater than H plus ion concentration. These solutions are, we said they are basic in character. So just by looking into pH value, we can classify whether the solution is acidic, neutral or basic. If pH is 4, we say it is acidic. Why? Because pH is 4 means H plus ion concentration 10 raised to minus 4. It means OH minus ion concentration 10 raised to minus 10. 10 raised to minus 4 H plus ion concentration greater than 10 raised to minus 10 OH minus ion concentration. So solution is acidic. If pH is 7 means H plus ion concentration is minus 7. OH minus ion concentration is minus 7. Both are equal. That's why it is neutral. If pH is 9 means H plus ion concentration is 10 raised to minus 9. OH minus ion concentration is 10 raised to minus 5. Minus 9 is less than minus 5. OH minus ion concentration is more than H plus ion concentration. That's why solution is basic. In that way, just by getting one number, we are able to classify solution whether it is acidic, neutral or basic. In that way, this scale is very important. So he used this scale and calculated the various values by using this. Then he applied this formula for POH also. POH also can be calculated just like pH. Only difference is it is negative logarithm of OH minus ion concentration. When we solve questions, you will understand how to use this logarithmic value. OH negative ion concentration is nothing but 10 raised to minus POH, and OH minus ion concentration is nothing but anti-log of minus POH. These are the various formula we need to understand here, and we need to use at appropriate time. That is why while solving the numerical questions. So formulas are important, and more important thing is what that formula means. That is the basic thing here. Now we'll solve one question which is always asked in theory examination. That is pH plus POH is equal to 14. This one formula will do. And they may ask us to prove this formula, deduce this formula, derive this formula. So we start with this H plus ion concentration multiplied by OH minus ion concentration is equal to ionic product of water. Of course, this they said at 290 Kelvin because then only this 14 number was valid. We'll take log of H plus ion concentration. And when we take log, there should be addition of these terms, OH minus ion concentration, log of ionic product of water. We have to take a log of all the terms. We'll multiply these terms with negative sign. So it is negative log of H plus ion concentration plus negative log of OH minus ion concentration, negative log of ionic product of water. Negative log of H plus ion concentration is pH plus negative log of OH minus ion concentration is POH minus of log of 10 raised to minus 14, which is minus, and log 10 raised to minus 14 is minus 14. This minus minus becomes plus. And that's why we can say pH plus POH is equal to 14. So this question, to prove this pH plus POH is equal to 14, this frequently asked for 2 marks. Only 2 steps we need to write here. H plus ion concentration to OH minus ion concentration is equal to ionic product of water. Log of H plus ion concentration plus log of OH minus ion concentration is equal to log of ionic product of water. Negative log of H plus ion concentration plus negative log of OH minus ion concentration is equal to minus of log of ionic product. Negative log of H plus ion concentration is pH. So pH plus as it is. Negative log of OH minus ion concentration is POH is equal to negative log of 10 raised to minus 14. Minus as it is. Log of 10 raised to minus 14 is minus 14. This minus plus. That's why pH plus POH is equal to 14. It's very important relationship we have. So this is about the pH plus POH is equal to 14. You have to prepare this question because it has been asked various times. Now we'll go for just like dissociation of water we have done. We'll go for dissociation of acid, which is weak acid, which is a reversible reaction. That only we are learning. And we'll go for dissociation of weak base also, because that is also a reversible reaction. And we may get equilibrium here. So dissociation of weak acid. Dissociation of weak acid is formic acid, acetic acid, hydrogen cyanide. We have seen this example. And dissociation of weak base. I will take these two cases simultaneously so that you will understand, you will compare, you will see the similarity. Once you know similarity, it is easier for us to understand the result. We will consider one weak acid, HA. This is weak acid. In aqueous solution, it dissociates as H plus ion and A negative Na. We can take Ha plus H2O, use hydronium ion plus A minus. That also will take. But we'll keep it simple. Ha gives H plus A minus in aqueous solution. Initial concentration. We consider as C. And there is no product present initially, so write at 0. This is one LP we have made. We have seen this type of situations in chemical equilibrium also. Change in concentration. Being reactant, it disappears by C into alpha. C is the concentration, alpha is degree of ionization. 50% dissociated means 50 by 100. Means 0.1 into 50 by 100 like that. And we'll consider that the same will appear here. So plus C alpha. And this is plus C alpha because reactants get consumed, negative sign, and products get formed, positive sign. So we can say now equilibrium concentration. How much is the equilibrium concentration now? C minus C alpha. C minus C alpha is C will make one common here. We will write 1 minus alpha. We will write the dissociation equilibrium constant for this reaction. We will write this now Ka as the suffix here, A for acid. It is nothing but H plus ion concentration, A minus ion concentration divided by HA. H plus ion concentration is C alpha. A minus ion concentration is C alpha. HA is nothing but C into 1 minus alpha. 1C we can cancel. That's why we can write Ka is equal to C alpha square 1 minus alpha. But as acid is weak, we assume that it is weak acid, then only this reversible sign will come, then only it will be established. Alpha is very low ionization, degree of ionization is very low. So 1 minus alpha is nearly equal to 1. So this 1 minus alpha is nearly equal to 1 means what? Ka is equal to C alpha square. Because this 1 minus alpha, we assume it as 1. So Ka is equal to C alpha square. We can write here alpha square is equal to Ka by C, and that's why alpha equals to square root of Ka by C. This is another result we are getting. And third point we want to make here is H plus ion concentration is equal to C into alpha. Alpha is square root of K into C. So that equals to K into C. Square root of K into C. H plus ion concentration is equal to K into C. So these three results, K into C alpha square, alpha is equal to square root of K into C. C is the molar concentration. And H plus ion concentration is equal to square root of K into C. Unequal. Now, similarly, you can derive this for dissociation of weak base. You can do yourself of BOH, aqueous. We will consider this as weak base. We will dissociate this and we will form B plus ion and OH minus ion. Similar thing, initial concentration. Right here C 0 0. Change in concentration. We write this as negative C alpha, C alpha, C alpha. And equilibrium concentration. And nothing but C minus C alpha, which is nothing but C into 1 minus alpha. C alpha, C alpha. Kb equals to B plus ion concentration, OH minus ion concentration. B stands for base here, divided by BOH. Just like A stands for acid here. Kw means W stands for water. Kc, C stands for concentration. Kp, P stands for pressure. So this Kb equals to molar concentration of B plus C alpha into C alpha. BOH is C into 1 minus alpha. This C we can cancel. We can write Kb equals to C alpha square divided by 1 minus alpha. Now we can say that base is weak, then only this equilibrium will be established. That's why we can say that alpha, degree of ionization, is very low. That's why 1 minus alpha is nearly equal to 1 and Kb is equal to C alpha square. That's what we get here. Alpha square is equal to Kb by C. That's why alpha is equal to square root of Kb by C. And OH negative ion concentration is equal to C alpha. Concentration is given. Or OH negative ion concentration is equal to square root of Kb into C. Molar concentration. So this 1, 2, 3, 4 results here. 1, 2, 3 and 4 these results. So this is very important formula because always question can be asked on this formula. We should know it's how we have derived it. Then it is easy for us to understand that if concentration is remaining same, H plus at concentration 1 divided by H plus at concentration 2 is equal to square root of Ka1 divided by square root of K by Ka2. That we can understand it. That is not that much difficult to understand that concept. What I am saying, if OH negative at concentration, this C is same. OH negative at concentration 1 divided by OH negative at concentration 2 equals to square root of Kb1 divided by Kb2. In that way, we can compare the basicity of two bases, or we can compare the strength of bases, or we can compare the strength of acid. We take questions, then we will understand it. So this is dissociation of weak acid, and this is dissociation of weak base. Now, what is important for us is to write again two formula so that we can go ahead. We will again make one list of formulas before solving the question, because there are so many formulas here. What formula I am talking about? H plus ion concentration 1 divided by H plus ion concentration 2 equals to Ka1 divided by Ka. This is one formula. Similarly, OH negative ion concentration, because concentration is same, CC get cancelled. Concentration is same, then only we are applying this formula. OH negative ion concentration 2 equals to Kb1 divided by Kb2, square root of course. And just like we have H plus ion concentration and pH, here we can have Ka and Pk. So we can write pKa equals to minus of log of K, and pKb minus of log of K. And we can write pKw is equal to minus of log of K. This formula also we can add here, which already we have seen. Now one more formula, one more relation, and we'll almost complete all this formula. That is pKa plus pKb is equal to 14. We have to prove this. This also can be asked for 2 marks. pK plus pKb is equal to 14. Now what we mean by pKa? There is nothing but we can start with this. K into Kb is equal to Kw. K into Kb, ionic product of what? 10 raised to minus 14. We can apply log to both sides. Log of Ka plus log of Kb equals to log of 10 raised to minus 14. We can write like this: log of K plus log of Kb is equal to log of 10 raised to minus 14 is minus 14. We multiply all of this equation with negative sign. Multiply with negative sign. Negative log of K plus negative log of Kb. Negative of negative 14. Negative of log of K is nothing but Pk. Negative log of Kb is nothing but Pkb. Negative, negative, positive, and it becomes 14. So this relation is also useful. We will use it whenever we solve the questions. So we have so many formulae, but we will number them and make list of them so that we can solve numerical questions in a better way. There is no need to feel it difficult because so many results are to be remembered. That's how the topic is. You have to remember all this formula. You have to use them when they are needed. So we'll see what type of all formulas which we have used today, so that we can use them while solving the questions. Right. So I will start from ideal product of water. The formula used. H plus ion concentration into OH minus ion concentration is equal to Kw, which is ideal product of water, which is 10 raised to minus 14 mole per liter square at 290 K. This is the first formula. Today we correct this. Then we said H plus ion concentration is equal to ionic product of water divided by hydroxyl ion concentration. Just rearrange this. OH negative ion concentration is equal to ionic product of water H plus ion concentration. Fourth is pH is equal to negative log of H plus ion concentration. H plus ion concentration is equal to 10 raised to minus pH. H plus ion concentration is equal to antilog of minus pH. Make this because square bracket means concentration of pH. Then seventh one, similar formula here, like pH. POH is equal to negative log of OH minus ion concentration. OH minus ion concentration is 10 raised to minus POH. OH minus ion concentration is equal to antilog of minus POH. pH plus POH is equal to 14. Then Ka is equal to C alpha square. Alpha is equal to square root of Ka by C. H plus ion concentration is equal to alpha into C. OH minus ion concentration is equal to square root of K into C. Alpha is equal to square root of Kb into C, if it is base. OH minus ion concentration is equal to alpha into C. OH minus ion concentration is equal to square root of Kb into C. Pk is equal to minus of log of K. Pkb is equal to minus of log of Kb. Pkw is equal to minus of log of Kw. Pka plus Pkb is equal to 14. H plus ion concentration 1, H plus ion concentration 2. Square root of K1, K2 at C constant. OH negative ion 1, OH negative ion 2 equals to Kb1, Kb2 at C constant. These are the various relations we come across today. You see this formula one by one. Try to understand the meaning of that. Molar concentration of H plus ion, molar concentration of OH minus ion, ionic product of water. Proteins of H plus ion is strength of H plus ion. And this anti-log law will see when we see the questions. This C is nothing but molar concentration, alpha is nothing but degree of ionization. Ka is nothing but dissociation constant of weak acid. Kb is nothing but dissociation constant of weak base. And this pK is nothing but negative log of K, like that. Now, one important relationship we can write here as pH is inversely proportional to H plus ion concentration, and pKa is inversely proportional to K. Means stronger acid greater K and smaller pK. Why we say so? Because of this negative sign. This negative sign indicate that they have the inverse relation between them, because this formula can be written as pH is equal to log of H plus ion concentration, and when we take the numerator, this negative sign comes. So we can have another relationship. That's why we written that pH is inversely proportional to H plus ion concentration. Means H plus ion concentration greater, pH is small. The pH and H plus ion concentration have same relation, which is pK and Kx. They are inversely proportional. The same thing is true for POH and OH, PKB and KB, PKW and KW. They are all inversely proportional to one another. So list is more, formulas are more, but for us important thing is what is meaning of that. What is the relation between various terms? If we understand that, our work is simple. Derivations are only to derive pH plus pOH is equal to 14 and pK plus pKb is equal to 14, or derive the formula for degree of ionization for weak acid. They may ask HA reverse is H plus A minus C 0 plus C alpha minus C alpha plus C alpha plus C alpha, C minus C alpha, C alpha, C alpha, like that we derive. So that derivation can be only asked for the marks. So make list of all these formula. Deliberately I have written it 2 times so that you can also write that. Have the calculator with you and log table with you so that we can use it. If you don't know how to use log table, I will explain it. But simple calculator and log table, these things always should be with you when you learn the physical chemistry. Same is true for physics also, right? So for timing, I will stop this video. You revise this concept, and next class we will try to use as many as possible as this formula. Right? Thank you.